Hi guys, welcome back to my channel. Before we start our new math lesson for today, please don't forget to hit the subscribe button and the notification bell for more videos. Just look for Teacher Dong. So our new math lesson for today, the power theorems. So we are still going to talk about the theorems about circles. So just like last week. So last week we were able to talk about angles formed by secants and tangents. So we're in that specific lesson we are able to solve for the angles formed between two secants, two tangents, and combination of two. And also, we're able to learn as well using the angle formed on how we can actually solve for the unknown or length of the segment. Okay, so in this lesson, let's talk about power theorems. But mostly, we are going to solve for the length or measurement of the lengths of segments or the whole secant or tangent. It depends on the theorem. So for my students and for the reference of my students, it's from page 198 to 207 of your books. Let's continue. So the first theorem is what we call the intersecting segments of chord power theorem. Again, the intersecting segments of chords power theorem, or we can also call it chord power theorem. So what is this all about? If two chords intersect in the interior of the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So just like what you are seeing here, we have this circle, and if you would like to solve for this segment, okay, or any of the four segments inside this circle, we can actually state this representation or equation. So it's now WE, or portion of the first segment, times OE, or segment OE. Okay, so you are just going to multiply the portions of the chord. Okay, in this case, the portions of the chords, we have segment W and OE. Just multiply them. Segment WE times segment OE is equal to the product of the other portions of the other chord. So we have segment PE, this one, and times segment RE. Again, you just need to multiply the portions of the chord equals to the portions of the other chord. So that's it. And in this theorem, just remember that we are talking about two chords. That's why we call it chord power theorem, or CCPT. And we are looking for the measurement of the segment. Now, let's have the first example. Find the value of x. So we have A, B, and C. Find the value of x. Okay, so in letter A, before we can actually solve for the value of x, you have to write your representation just like this. The first portion, let's talk about segment LE or chord LE. And then in chord LE, there are two portions. So we have segment LM, then you will multiply to segment EM equals other chord. We have chord OV, so we will have segment VM times segment OM. So this is now your representation. Portion times portion of the first chord equals to the portion times the portion of the other chord. That's it. And then after that, let's substitute the values. Segment LM is x times segment EM is 8 equals segment VM is 6 times segment OM, which is 4. And then let's simplify. X times 8 is 8x equals 6 times 4 is 24. Then to solve for the value of x, we have to divide both sides by 8 to isolate x. Okay, 8 divided by 8 is 1, so that it's 1. And then 24 divided by 8, it's now 3. So the value of x here is 3. That is also the length of segment LM, 3 units. Okay, that's it. So the first thing is you have to analyze the given diagram or illustration, and then after that you have to form your representation just like this before you can substitute and solve for the unknown measurement. Now let's have letter B. So we have this circle, and then we are solving for the value of x. So first we have to write our representation. So segment VA. Okay, so we are talking about the first chord times segment RA equals segment EA, the other chord, times segment CA. So the next thing that you're going to do is to substitute the values. VA is 3, or segment VA is 3. Then segment RA is 18. Okay, this one is segment RA. Then segment EA is 3x times segment CA, which is 2x. Then the next thing, we will multiply. 3 times 18 is 54. Then 3x times 2x, we will be applying multiplication law of exponents. So just copy the base, which is x, and then add the exponents of x. So 3 times 2 is 6, and then we have x squared. Then the next thing is we will divide both sides by 6 to isolate x squared. So 6 divided by 6 is 1. So x squared will be 54 divided by 6, or 9. Then since this has a square, so we have to extract the square root of both sides. So square root of x squared is just simply x equals square root of 9. In reality, it's positive negative 3, but we will just be accepting the positive answer. So because we are talking about measurement of the length of the segment. Okay, so the value of s that we are going to accept is positive 3. Okay, so let's have letter C. For letter C, same thing. You have to analyze the given illustration, and then after that, you have to form your equation. So for the equation, it's segment BV for the first chord times segment EV, the other portion of the first chord. So this is BV, this is EV, equals segment AV, the other chord. This one is segment AV times segment RV. Then the next thing that we're going to do is to substitute the value. Segment BV is x times segment EV is 8 minus x. So remember that we're solving for the value of x here. And then segment AV is 3 times segment RV, which is 4. Then we will simplify. Since this is monomial and then this is binomial, we will distribute x. So x times 8 is 8x, and then x times negative x is negative x squared. Then 3 times 4 is 12. So this will become a trinomial. So we will be transferring the 2 by addition property of equality. Get their opposite. Opposite of negative x squared is positive x squared, and then opposite of 8x is negative 8x. Just bring down 12 because we did not do anything. So plus 12 equals 0. This is now a trinomial. So in trinomial, we need to factor for us to be able to get the values of x, or variable. So in this case, we will just be using cross method because that's the easiest, wherein we will be factoring the first term, the last term to get the middle term. So the factors of the first term, we have x and x. Then for the last term, we have to get negative 8x. So since this is positive 12, so the factors are both negative. So let's try using negative 2 and negative 6. So if these factors will not work, okay, use other factors. So x times negative 2, it's negative 2x, and then x times negative 6 is negative 6x. Then just add them, you will be getting negative 8x. So it means that the factors are correct. So we now have the factors. X minus 2 times x minus 6 equals 0. Now we can now solve for x. X equals 2 here, and then x equals 6 here. So as you can see, they are both positive, so we will be accepting them as both values of x. So the values of x are 2 and 6. So you will not accept if one is negative. Okay, so just remember that. That is Theorem 116, or the chord power theorem. So in this case, we have two chords intersecting in the interior of the circle. So that's the marking, or that's the hint that you will be using Theorem 116, or the chord power theorem. Next, let's have Theorem 117, the segments of secants power theorem. So the segments of secants power theorem, in short, we call it SSPT, or secant power theorem. So because there are, in the previous theorem, there are two chords intersecting in the interior, but in this case, the two secants are intersecting at the exterior of the circle. So if two secants intersect in the exterior of the circle, the product of the length of one secant segment and the length of its external part is equal to the product of the length of the other secant segment and the length of the external part. So to better understand this, guys, in the previous theorem, we are multiplying portion equals portion. But in this case, we're going to multiply the portion and whole of the first secant and then equals to the portion and the whole of the other secant. So how is that? In this case, you will multiply WE times the whole WR. That's it. And WR contains the sum of WE plus ER. So take note of that. And then WP, the portion, times the whole WA. Okay, and WA is the sum of WP plus PA. Okay? So this one is the combination of that, is the sum of the two chords. The sum of the two segments of the secant, sorry. Okay, so that's it. It's portion times whole equals portion times whole. In the previous theorem, it's portion times portion equals portion times portion. So I'm interpreting it like this so for you to be able to easily understand it. That is Theorem 117. So what is the hint? There must be two secants intersecting at the exterior of the circle. So let's have the second example. Use the illustration to answer each item. Let's have letter A. So this is the illustration. Okay. So as you can see, there are two secants that are intersecting outside the circle. So how are we going to solve for this one? First, you have to form your equation. Okay. VO, which is the portion, times the whole. Okay, that's it. So the main equation is VO, segment VO times segment VL, wherein segment VL is the sum of segment VO and segment LO. Equals, okay, the portion of the other, which is segment VE, times, okay, the whole, which is segment VD. So segment VD, just remember, it's the sum of segment VE plus segment VE. Okay, next. So since we already have our representation, let's have letter A. If segment VO is equal to 12 and segment LO is equal to 18 and segment V is equal to 16, find segment VD or the whole. Okay, so segment VO, substitute the value, which is 12 times, okay, segment VL contains the sum, is the sum of the VO and LO. So you will be adding 12 plus 18. Equals VE is 16 in the other side times segment VD, which is the unknown. So segment VD is the one that we are looking for here. So the next thing is you will simplify 12 plus 18 is 30. So bring down 12 times 30 equals 16 VD. Then the next thing is 12 times 30 is 360 equals 16 VD. So to simplify this, we have to divide both sides by 16. So this will become 1, and then 360 divided by 16 is equal to 22.5. So that is the length of segment VD. So we are able to solve it using the representation segment VO times segment VL is equal to segment VE times segment VD. So that's it. Now let's have letter B. If segment VO is equal to 6, segment LO is equal to X, segment V is equal to 8, and DE is equal to 18, find LO. So we're looking for the portion which is LO. So in this case, let us substitute the values. 6 is VO times, so 6 plus X. Okay, 6 plus X because 6 is the length of VO and then LO is X. So if we're going to combine them, it's the measurement of segment VL. So segment LO also is X, so which is the one that we are solving. The segment VE is 8 times 8 plus 18. Because segment VD is the sum of segment VE and DE. Then the next thing is we will distribute the monomial to the binomial. So we're going to have 6x plus 36. Or 36 plus x, so that you will not be confused. So I just arrange it. Next, equals 8 plus 18 is 26. Then multiply the 2. 8 times 26 is 208. Bring down 6x plus 36. Then the next thing is you have to isolate 6x by removing 36 here using addition property of equality. So 208, and then the opposite of 36 is negative 36. So just subtract them. 6x is equal to 208 minus 36 is 172. So to get the final answer, divide both sides by 6. So therefore, x is equal to 172 divided by 6 is simply 28.67. and x is what we call the value of segment LO. So this will serve as your final answer. So the measurement or the length of segment LO is equal to 28.67 units. Now let's have letter C. So if segment VO is x and segment LO is x plus 2, segment V is 5, and segment D is x plus 2, find x. So segment VO is x times segment LO, okay, just add, times segment VL, or just add x plus 2. So x plus 2 is LO and VO is x, the whole, equals VE, which is 5, times the 2, 5 plus x plus 2. Then we are going to solve for x. So let's combine the similar terms. So x times x plus x is 2x plus 2. So we just combined x and x, equals 5 times 5 plus 2, similar terms are 5 and 2. So 5 plus 2, we have x plus 7. Then the next thing is, we will distribute the mono to the binomial. So x times 2x is 2x squared. And then x times 2 is 2x, equals 5 times x, or 5x, plus 5 times 7, which is 35. Then the next thing that we're going to do is to simplify this, or combine the similar terms. So 2x, bring it down to x squared, plus 2x, what is similar to 2x is 5x. So it's negative 5x. And then minus 35 equals 0. Okay, so let me erase it first. Equals 0. Then the next thing is 2x minus 5x. We have negative 3x. So bring down 2x squared minus 3x. Then minus 35 equals 0. So this is now a trinomial. Same thing. We will be factoring the first, the last to get the middle term. Okay. So for letter C. So let's try the following factors, 2x and x for the first term. And then for the last term, let's try, since this is negative 35 and then the middle term is negative, so the factors are negative and positive, or positive or negative. So let's try positive 7 and 5, negative 5. Then cross method, x times 7 is 7x, and then 2x times negative 5 is negative 10x. So 7x minus 10x is negative 3x. So therefore, the factors are correct. The factors are 2x plus 7 times x minus 5 equals 0. So the next thing is, let's solve for x. So 2x equals negative 7. So divide both sides by 2. X now is equal to negative 7 halves, which is rejected because the sign of the answer is negative. But here, let's see. So x minus 5 is x equals positive 5. So therefore, the value of x that we are going to accept is x equals 5, or positive 5. So that's the value of x that we are looking for. Again, just remember, for Theorem 117, we have two intersecting secants, and the intersection is outside the circle. Now, to solve, okay, just multiply the portion times the whole of the first secant equals to the portion times the whole of the other secant. As simple as that, so that you will not be confused. Next, let's have the last theorem that we're going to talk about. Theorem 118, the tangent secant segments power theorem. So in the first theorem 116, it's chord, and then in 117, it's secant. This time, it's a combination of tangent and secant. And the intersection is still outside the circle. But the thing is, we have tangent and secant. So it's actually quite similar to Theorem 117, but let's see what's the difference. If a tangent segment and a secant intersect in the exterior of a circle, then the square of the length of the tangent, so we need to square the tangent segment, is equal to the product of the lengths of the secant segment and its external part. Okay? So, to solve for the unknown segment, so you will have to square the tangent. So because we only have one portion of the tangent, okay, so it's now EB squared equals LB portion and the whole. So it's similar to Theorem 117. It's just that we are dealing with only one secant. So segment LB times segment UB, or the whole, and then just square the tangent EB squared. So EB squared is equal to LB times UB. As simple as that. Okay? Next, let's have example number 3 applying Theorem 118. Okay? So letter A, if segment CI is equal to 8 inches and segment ID is equal to 10 inches, find segment CR. So before we start, so let's analyze first the given illustration, and then after that, we have to form our equation that we are going to use. So this is the illustration. Okay? So form our equation, which is the tangent is CR, obviously. So we will square CR. So CR square is equal to portion, which is CI, times the whole, which is CD. So just remember that CD is the sum of CI plus ID. Okay? So let's have letter A. So CI is 8. So we are looking for segment CR. So we need to square segment CR equals CI, which is 8 inches, times, okay, so the whole, which is the sum of 8 plus 10, or CI plus ID. Okay, that's it. Then the next thing that we're going to do is to combine the similar terms. So bring down CR square equals 8 times 18. And then 8 times 18 is 144. Bring down CR square. So to solve for this one, extract the root of both sides. So segment CR is equal to 12 inches. So let's put the unit. So segment CR is equal to 12 inches. So we applied Theorem 118 here based on the illustration. Now let's have letter B. If segment CR is equal to 6 inches, segment CI is equal to X, and segment ID is equal to X plus 1 inches, find segment CD. So in this case, we are looking for the whole measurement of segment CD. So this is what we are going to do. Segment CR, or the tangent, is given as 6. So we will square that. Equals segment CI, which is X, times the whole, CI plus ID. So X for CI, and then X plus 1 for ID. Then the next thing is 6 square, or 6 times 6 is 36, equals X times X plus X, 2X plus 1. Then distribute X, bring down 36. So X times 2X is 2X square. Then X times 1 is X times 1 is X. Then the next thing that we're going to do is to simplify this by making it a trinomial. So we will be transferring 36 using addition property of equality. So it's now 2x squared plus x minus 36, which is the opposite of positive 36, equals 0. Then the next thing is trial and error. We will be getting the factor of the first, the last, to get the middle. So in this case, we have a combination of positive and negative factors. So 2x and then x. Then negative 36, let's try if 9 and negative 4 will work. So x times 9 is 9x, and then 2x times negative 4 is negative 8x. So 9x minus 8x is just simply x. So therefore, the factors are correct. So the factors are 2x plus 9 times x minus 4. Okay, then the next thing that we're going to equal 0, solve for x. So 2x equals negative 9. So as you can see, it's rejected because it's negative. So divide both sides by 2. X is equal to negative 9 over 2. So this is rejected because it's negative. X minus 4 is equal to positive 4. The value of x that we're going to use is positive 4. But since we're looking for segment CD, which is the sum of CI and ID, okay, substitute the values. So CI is x, and then ID is x plus 1. Combine. X plus x is 2x plus 1, and then the value of x that we are able to solve is 4. Substitute that. So 2 times 4 plus 1, 2 times 4 plus 1 is equal to 9 inches. So the value of segment CD is 9 inches. Okay, that's it. Now let's talk about further theorem relating with this example. So as you can see, it's quite complicated if you will just look at it at first. So but it's not. So this example is actually very easy. Find the value of x and y. So for letter A, to solve for the value of x, so of course we are going to use Theorem 118 here, or the secant tangent power theorem. So to solve for the value of x, you have to first form your equation. So this is the tangent and this is the secant that we're going to use. So segment LO square is equal to segment LV times the whole segment LR. Okay, then substitute the value. Segment LO is 6 square equals LV, which is 4, and then LR is the sum of 4 plus x, or LV plus VR or RV. Then the next thing is 6 squared is 36 equals distribute. 4 times 4 is 16. 4 times x is 4x. Then the next thing is combine the similar terms. Okay, 36 minus 16, opposite of 16 is negative 16, equals 4x. So 36 minus 16 is 20, equals 4x, and then divide both sides by 4. Therefore, the value of x that we have here is 5. So let's put it here, it's 5. Now we can solve for y. So to solve for y, we will still be using Theorem 118. So this time, this is the tangent, or segment LE square, and then this is still the secant, LV square. No, it's not LV square, it's just LV, sorry for that. So it's LV times LR, or the whole. Then the next thing is LE square is the missing, so we will put y square. And then LV is 4 times 4 plus 5. So 5 is the value of x a while back. And then 4 times 4 plus 5 is 9. So 4 times 9 is 36 equals y squared. Then extract the root of both sides to remove square. So y is equal to 6. So the value of x is 5 and the value of y is 6. So the measurement of this tangent is 6. Next, let's have letter B. Same thing. This time the tangent is at the middle. So to solve for x, still we will be using Theorem 118. So our equation now is GE square equals GA portion times the whole GM. Then the next thing is substitute the values. GE is unknown, which is x squared, and then GA is 8 times 8 plus 10, or the whole. And then 8 plus 10 is 18. Bring down x squared. X squared is equal to 8 times 18. Okay, so 8 times 18 is 144. Then extract the root of both sides. X is equal to positive 12, or square root of 144 is positive 12. So the value of x here is 12. So we can now solve for y, still by using Theorem 118. So the equation is GE square is equal to GR times the whole GS. Then the next thing is GE is 12. We are able to solve that. And then GR is 4 times 4 plus y. Then 12 times 12 is 144, and then distribute 4. 4 times 4 is 16 plus 4y. Then combine the similar terms. 144 minus 16, the opposite of 16, equals 4y. So 144 minus 16 is 128, equals 4y. Let me remove this. And then divide both sides by 4. So the value of y will be equal to 32. So the value of x is 12 while the value of y is 32. Okay, so that is Theorem 118. Alright, so we are able to finish the 3 theorems here. Now let's have this last example. Example number 5. The segments of one of the intersecting chords are x plus 2 and x plus 6, and x minus 4 and x plus 18 for the other chord. Find the length of each chord. So we are talking about two chords that are intersecting inside the circle. So therefore, we will be using Theorem 116, or the chord power theorem. So as you can see, the length of the first chord, we will multiply portion times portion. So x plus 2 times x plus 6 for the first chord, and then for the other chord, we have x minus 4 times x plus 18. So as you can see, we are multiplying two binomials in the two sides of the equation. So we will just be using FOIL method here to easily solve. So first term, x times x is x squared. Outer, x times 6 is positive 6x. Inner, 2 times x is 2x. And then last term, 2 times 6 is 12. And then in the other side, x times x is x squared. Outer, x times 18, we have 18x. Inner, we have negative 4 times x, negative 4x. Last term, negative 4 times negative 18 is negative 72. Then combine the similar terms, x squared, then 6x plus 2x is 8x plus 12. Then in the other side, x squared, then 18x minus 4x is positive 14x minus 72. Then the next thing is we will be combining the similar terms. X squared is similar, so it's negative x squared because we will be transferring. Now 8x, and then opposite of 14x is negative 14x. And then equals negative 72. Opposite of 12 is negative 12. We just rearrange it, no? And then x squared minus x squared is 0. Then 8x minus 14x is negative 6x. Then negative 72 minus 12 is negative 84. And then divide both sides by negative 6. So therefore, x is equal to positive. It's now positive 14. Okay? Now, we're not just looking for the value of x. We need to find the length of each chord. So the first chord is x plus 2. And the value of x is 14. 14 plus 2 is equal to 16. And then the other segment, we have x plus 6. We have x plus 6. Okay, so value of x 14 plus 2. Okay, 14 plus 2 is, no, 14 plus 6 is 20. So the length of the first chord will be 16 plus 20. So 16 plus 20 is 36 units. So that's the length of the first chord. While for the second chord, okay, x minus 4, the value of x is 14, minus 4, it's 10. And then the other one, x plus 18, the value of x is 14 plus 18 is equal to 32. So for the second chord, you will just add 10 plus 32 equals 10 plus 32 is 42 units. So the length of the first chord will be 36 units while the other chord is 42 units. So that's it. So please don't forget the differences among the three theorems that we have discussed for today. Alright? So for my students, you please do this activity. If you have questions and clarifications, most especially to my students, please don't forget to contact me. And then to those who are watching, if you have comments and suggestions, you can comment down below. So thank you so much for always supporting my channel. And then to those who are not yet subscribed, okay, please hit the subscribe button and the notification bell. Just look for Teacher Dong. Okay, so thank you so much for being with me. Have a nice day, everyone.